Oh, we're live. Okay, so we've got, as a 15,000 kilogram jet plane lands on an aircraft carrier, its tailhook snags on a cable to slow it down. The cable is attached to a spring with a spring constant of 60,000 Newton meters. If the spring stretches 30 meters to stop the plane, what is the plane's landing speed? So when we go about these problems, we always want to look at what we have. We've got a mass, which is 15,000 kilograms. We have next spring constant, so K, equals 60,000 Newton meters. And we have a distance, X is going to equal 30 meters. Now, what we're looking for is the velocity of the plane before it lands. So when we have this, we know we're going to be looking for the kinetic energy of the jet because the jet is moving before it stops. And we know that we have the spring, so we're going to looking at the potential energy of the spring. Those two equations are going to be KE equals 1/2 mv squared and PE equals 1/2 kx squared. Now, with this in mind, we know that because of the law of conservation of energy, these two are going to be equal to each other. So we can go ahead, set those there right now. 1/2 mv squared is equal to 1/2 kx squared. And now we're going to simplify this so that we can solve for that velocity. First thing we're going to want to do is multiply the equation both sides by 2. That's going to get rid of these 1/2s. Get mv squared equals kx squared. Then what we're going to do is isolate that velocity. So we've got v squared equals kx squared over m. And finally, we're going to take the square root so that we can isolate v rather than have v squared. V is going to equal the square root then of kx squared over m. Then we're going to take all these values that we found from the problem and plug them in right over here. We're going to get v is equal to the square root of 60,000 Newton meters times 30 squared over 1,000, excuse me. And that's going to simplify easily down to v equals 60 meters per second.